Okay, so let's move on with this table in part 2. So we're looking at 2018. We've just done up Kc for the reaction on the right hand side, and now we've got the table here that we're going to fill out. So looking at the question here, we have seen that a 12-litre container was filled with 0.2 moles of chlorine. So we're going to put in 0.2 moles for chlorine there. Because this is a 1:1 reaction, this also has to be 0.2 on the left hand side, and the right hand side this has to be 0 because nothing has been formed yet. Now we've got to look at the change if there's one of the question, and we've got to look at equilibrium. Now it does tell us in the question here that if 85% of the chlorine gas had reacted, and it's 85% of the chlorine had reacted. So over here, 85% of the chlorine gas reacted. Now if you initially had 0.2 moles of Cl2, then you're going to get 85% of that. So 85% of 0.2 moles is going to give you a final of 0.17 moles. So remember, this is what reacted. So at equilibrium, you have lost 0.17. You can write it in like this, minus 0.17, that's how much you're losing. And if you lose minus 0.17, then of course you're going to end up with 0.03. Now from this you can go figure out the other boxes. So if you've lost 0.17, because this is a 1:1 reaction, you also have lost 0.17 here. And again, because of 1:1 reaction here, that means you are going to gain 0.17. You don't gain 0.34. You don't just add these numbers. In the same way, we always use the analogy of the cake. Just because you put in a cup of flour and a cup of milk, that doesn't necessarily mean that you only get 2 pancakes. So you don't just add numbers and then get the same out on the other side. We can work on the equilibrium here as well, which is 0.03. And because this is initially 0, the change is plus 0.17. This is also 0.17. One thing we've got to be careful of here is we are dealing with a 12-litre container. So a 12-litre container means that you have to divide everything across by 12 because everything has to be done in a 1-litre container. So 0.03 divided by 12, it's going to be 0.03 divided by 12 and 0.17 divided by 12. And your final numbers then at the end, so at equilibrium proper in 1 litre, you're going to be dealing with 0.0025. And 0.0025, and this is 0.014167. So let's go put them into this Kc equation up here, and we should get out our final answer. A bit of space. So popping into Kc, so our Kc is going to be 0.014167, all divided by 0.0025 multiplied by 0.0025. And when you work that out, Kc then gives you a final value of 2266.72. And again, we're going to leave the answer at that. If you're unsure, don't round, just leave it as it is, unless it says so and the question says something different. Okay, moving on to the next question. We're looking at 2017 now. Consider the following chemical equilibrium that's established. And we have N2O4 and an equilibrium that gives us 2NO2. So write an equilibrium constant for this reaction. So again, Kc for this reaction is going to be the right-hand side, which is NO2. And you'll notice the NO2 has 2 at the front of it. So that means we're going to square that value. And then we're going to have N2O4 on the bottom, no powers there. Then part C says the value of Kc for the reaction at T is 0.2, and that's important. So we have got to say Kc is 0.2. So this number is going to be 0.2 when we go to do our calculations. I'll draw up the table and I'll be back in one moment. Okay, so let's have a look at the table here now that we've got it drawn up. So we've got N2O4 at the top and we have 2NO2 and we have our equilibrium. arrows in the middle. So we've initially changed at equilibrium, and this one is a 10-litre container. So again, we have to take that into account. There's the 10-litre container there. So initially, what have we got? So it says 1 mole of pure dinitrogen tetroxide. So dinitrogen tetroxide means there's 4 oxygens. So that's obviously the first one. So initially, we're going to go with 1 mole of this. On the other side, initially, we're always going to have 0 because nothing has been formed. Now, it doesn't say anything else here about whether there was a change. It doesn't tell you anything about at equilibrium mixture. So obviously, we're going to be dealing with algebra here. So the first thing we have to look at is where to put the x. So normally when we put the x in, we would normally say, okay, 0 has been formed in this particular box here. So the change then is going to be plus x. And this would normally be our first move. So if we put plus x here, we'd normally go back to this side and we will put plus x in here. But we can't do that in this situation. And the reason for that is this is a 1 and this is a 2. So this is a 1:2 ratio. So if you put plus x in this box here, you cannot put plus x in here. Because it's a 1:2 ratio, this is going to have to be a half x. Now, again, also, let's get rid of that now. Let's get rid of that. And also, not only that, it's going to be minus 1/2 x. Because this is the left-hand side of the equation. So, because of 1:2, this is plus 1, this is minus 1/2 x. So, at equilibrium, what's going to happen here is this is going to be just x, and this one over here is going to be 1 mole minus 1/2 x. There is an alternate way of doing this if you wanted. You could, if you wanted, set that at 2x. And if this was 2x, then this one here would be 1x. And you can work through your calculations then continuing like that. It doesn't really matter as long as this box here is twice the left-hand box, then you're going to be okay. So, continuing on with this, we've also got to divide by 10 because we've got 10 litres here. So, this one here is going to be working out finally at 1 minus 1/2 x, and that's all over 10. And this one here is going to be x over 10. You now have to pop this into your KC formula, and there is quite a bit of maths in this. So let's have a look at it and see. Let's make a bit of space. So popping these in, we're going to end up with 0.2, because in the question it tells it that Kc is 0.2. And that's going to be equal to x over 10, which is the NO2 on the right hand side, and that's got to be squared. And all of that is going to be over N2O4, which is going to be 1 minus 1/2 x over 10. There's no square power on that. And again, we've got to try and tidy that up. So we've got 0.2, it's going to be equal to, and again, square this out, we've got x squared over 100 on the top, and then on the bottom, there's not an awful lot we can do with that for the moment. That's over 10. Now, from where you go from here is up to yourself. There is a few ways you can do it. The way I approached it was I brought this up from the left hand side, and I ended up with 0.2 multiplied by 1 minus 1/2 x all over 10, and that equals x squared over 100. And then I multiplied this left hand side out. There is other ways you can approach this. You can multiply above and below here in the left, but this is the way I did it. So this gives me 0.2. So I'm going to multiply the 0.2 by the 1 and then the 0.2 by the minus 1/2 x. That gives us 0.2 minus 0.1 x, and all of that then is over 10, and that equals x squared over 100. If you want, you can cross multiply, or you can multiply across by 10, whatever way you want to do your maths, there's multiple ways of doing it. But for this one here, I just multiplied across by 10. Multiplying across by 10 gets rid of the 10 on the bottom. So I ended up with 0.2 minus 0.1x equals, multiplying the right hand side by 10 gives me 10x squared over 100. And again, once you have 10x squared over 100, just for handiness sake, you end up with 0.2 minus 0.1x is equal to x squared over 10. And again, I brought the 10 up here. When I brought the 10 up, space. So when I brought the 10 up, I ended up with 2 minus 1x is equal to x squared. As you can see, you have an x squared and x in a number, you've got a quadratic equation. So this is going to give you x squared, and I'm going to bring over the minus 1x and the 2, plus 1x minus 2 equals 0, and then you factorize. So simple factorization, you got to come up with minus 2, so we're looking at plus 2 and minus 1 to work out that. So you end up with x equals minus 2 and x equals positive 1. So there are your two answers. You're not going to take this because if x up here is the change plus x, the number that you're looking for down here is x equal to 1. So now what we can do is if x is equal to 1, that means this one here is your NO2. So let's go back down here. So if x equals 1, 1/2 x is equal to 0.5 moles per litre. And that 0.5 moles per litre is your N2O4. And then your x, which you figured out earlier on, x is equal to 1 mole per litre. And that there is going to be your NO2. Or in fact your 2NO2. Again, some people look at it and kind of go, why didn't you double the 1 to 2 because you've got 2NO2? Because we said that 2NO2 was just x. So 2NO2 equals x. So that's where you get that. And that's the final answer there.